Hello students, this is Kawaljit Singh from Rasa International School. Today we will discuss the topic motion from class 9th science. In this topic we will cover the following points: introduction, type of motion, physical quantities, distance and displacement, uniform and non-uniform motion, speed and acceleration. To understand the topic motion, we have to understand first what is point object, what is frame of reference, what is rest state, and what is motion. So a rest state is a state where the object does not change its position with respect to time. Now what is position? So you are at your home, then your position is at your home. If you are moving on a road, you are changing your location or position time to time, okay, because you are in motion. So rest state where the object is not changing its position with respect to time. So in your home you find various objects like TV, refrigerator, sofa, chair, table. They don't change their position with respect to time, and they are said to be stationary or at rest state. But many objects which change their position with respect to time, like if you are driving a car or a two-wheeler or a cycle, then you are changing your position with respect to time and your surrounding. Means if you see your left or right, you will find that the frame or the scene is continuously changing because you are in motion. So the frame of reference, if anyone sees you, then he or she will be able to find that you are in motion because the scene behind you is changing continuously because of your motion. That example can be seen over here in figure number 1 and figure number 2. If a person standing on road, okay, sees that, then he will find that the car in figure 1 is on the right side of the tree, but in figure 2 the car is on the left side of the tree. The figure 2 is after 2 seconds of figure 1. The figure 2 is captured after 2 seconds of figure 1. So from there he or she can state that the car is in motion and the tree is at rest, or you can say the tree is a frame of reference to see the motion of car, or the scene behind the car is a frame of reference to see the motion of the car. So now what is frame of reference? It is another object or scene. So here the object is tree, or scene is where the tree and the buildings are there behind the car, with respect to which we compare an object's position. So from whose we are able to compare the position of the object. So here we can say that the car is in motion. Now next is types of motion. They are basically the following types of motion. First one is translatory motion, second is rotatory motion, and third is vibratory motion. Translatory motion is been further divided into two categories: rectilinear and curvilinear motion. There is one more type that is known as random motion. Now, translatory motion is a motion where the particle moves from one point to another in space. Now, particle means most of you seen that in sunlight there are many dust particles we are able to see from a slit. If the light is coming, you find or you can able to see that the dust particles are continuously moving in that region. So, particle or a body when change its position in space from one point to another, then it's said to be in translatory motion. Now, translatory motion is being categorized on the basis of the path covered by the body or the particle, if it is straight or curve. So first one is rectilinear motion. The motion along a straight line is called rectilinear motion. So if car is moving on a straight road, then it is in rectilinear motion. And curvilinear motion, if the car is moving in a curved path, then it is in curvilinear motion. So here you are able to see in figure the car is moving in a straight road and the car is moving in a curved path. So we are able to see that the translatory motion is being divided into two categories, that is a rectilinear motion and curvilinear motion. Rotatory motion is a motion where the particles of the body describe concentric circles about the axis of motion. Now, when we can say that the particles of the body, that means the body is made up of different particles, and means there are n number of particles in the body, and each particle, when the body rotates, there is an axis of rotation, and these particles make concentric circle about that axis. So that axis, that means to say that these circles will have the common center, and this type of motion is known as rotatory motion. So here you can see the blades of the fan are in having n number of particles, and these particles are making concentric circles, and the top is rotating about the fixed axis, and the top is also making of n number of particles where they're making concentric circles about the axis of rotation. Now vibratory motion. In vibratory motion, the particles move to and fro about the fixed point. Like in wall clock, if you have a pendulum, then what it can see. So here we can see that the pendulum moves left and right. Okay. And this left and right movement is to the extreme left, then to the extreme right. Then this type of motion is known as vibratory motion. Even in musical instruments like sitar, guitar, you will find there are strings which have been stretched up with a knot, and when we flip them, then they will vibrate up about their mean position. That type of motion is known as vibratory motion. Even in seesaw, which the students used to play with, they are also under vibratory motion, in which one student get up, then the other will go down, then the second will go up, then the first will go down. This is also vibratory motion. Now we have to discuss about physical quantities. Ac- Actually, physical quantities are those in which we have two types, like scalar one and the vector one. It is the physical property of the material that can be measured. Means suppose we have length with us. Okay, so there's a wire, so we can measure the length. Yes, we can measure the length. So it is its physical property of the material. So similarly with a body is with us, then we can say that what is its mass. So it is again its physical property that can be measured in different units, and whether they have the direction or not. So scalar quantities are those which have magnitude only. Magnitude means value, the numerical part. Okay, so here we have an arrow on the right side in the figure, and if I ask you to take the length of this arrow, so you can take the length, and that length is the magnitude. That length will be the magnitude. So therefore scalar quantities does not have direction, but in vector quantities they have magnitude as well as direction. Now this can be understood easily. In this figure, the arrow has a head and a tail. So suppose you are moving on a road and you find that the road is straight, or we can take an example that if a person asks you to take three steps, then you can take three steps in any direction, towards your left, right, in front or back. Okay, but if I ask you to take three steps in north direction, then I've specified that you have to take three steps in north direction. Now here the value plus direction is being given to you. So this type of quantities are known as vector quantities. So for example of physical quantities of scalar one, we can write time, number of person, speed, distance, because they don't have any direction. Apart from that, the example of vector quantities, we have displacement, force, acceleration, momentum, velocity. These we discuss in our next slide. Okay, so why they are being vector and why they are scalar. Distance and displacement. Now you are able to see in the figure there's a school and a home. From school to home, you can find the red lines indicating the distance which a person travel through the road to move to home. Whereas a straight line between school and home is being drawn with green color showing the displacement. Now what is that? From where you start your motion, that position is known as initial position. So school is the initial position, and where you reach, finally you stop, is your final position. So home is your final position. So keeping in this mind initial and final position, and the path you travel, the actual path you travel from initial to final position is the distance traveled. So it has been noted over here. Distance covered by a moving object is the actual length of the path followed by the object. So when you move to your home, you will follow this road to reach to your home. So this is your the actual length which you cover while moving from school to home is your distance travel. But what is displacement? It is the shortest distance between initial and final position. Initial is your school and final is your home. So therefore distance is a scalar quantity because here we don't specify the direction. But displacement is a vector quantity because it here we have specified that the straight line distance between the initial and final position. So here the direction is specified. So from the initial point you find where in which direction the final point is. Then you what you do, you will connect a straight line or a line of sight path, that is that length will be your displacement. Distance is always positive because when you move there must be some distance or some length covered. Displacement can be positive or negative. Suppose you start your motion in the north direction and you come back along the same path or through different path and you and your motion to the right of, or you can say to in the south direction from the initial position, then your displacement will be negative. The negative don't means that your displacement is negative, means it shows the positive or negative sign of the displacement shows the direction of motion. There's always a distance covered whenever there is a motion. Displacement can be zero, positive or negative. As I told you, displacement can be zero, negative or positive. The SI unit of both is meter. The SI unit of both is meter. In the figure 2 also you can see that from A to B the distance traveled is indicated through the red line and the displacement is the straight line distance between initial and final position. Now here we have one more example to understand distance and displacement. The distance between A and B is 100 kilometers. Okay, so from point A to point B it is 100 kilometer. So the bus travel from A to B first, then from B to A. So finally it stop at A. So the initial position is also A because it started from here, and the final position is also at A because the bus stop at A. So that is your home, from home to school and from school to home. So the total distance traveled will be AB plus BA, that is 100 plus 100, 200 kilometers. And the total displacement, because there is zero distance between initial and final position, so we can say the displacement is 0 kilometers. Now we can understand this. Which of the following is true for displacement? It cannot be 0. As we studied in our last slide that displacement can be 0. So it is not true. A is not true. Displacement can be 0 when initial and final position of the object is the same. The magnitude is greater than the distance traveled by the object. The magnitude of displacement can never ever be greater than distance traveled by the object. It can be equal or less than. It can be equal or less than or be 0 or be 0. So it is also not true. Displacement is the shortest measurable distance between initial and final position of the object, it cannot be greater than the magnitude of the distance traveled by an object. However, sometimes it may be equal to the distance traveled by the object. So it should be clear in our mind. Uniform and non-uniform motion. Uniform motion is a motion where the object travels equal distance in equal interval of time. Like in, you can see in car X is over here. So here it is, time is given as well as the distance travel in particular time is also been provided to you. So from point A to point E, you can see that in every 2 seconds the object travel 10-meter distance. That means the distance traveled in equal time is equal. So it is a example of car X is an example of uniform motion, where you can see in car Y, in each second the distance traveled is not equal. So it is an example of non-uniform motion. It is an example of non-uniform motion. So uniform motion is a motion when the object cover equal distance in equal interval of time, and non-uniform motion when an object moves unequal distance in equal interval of time, or you can say vice versa, that means equal distance in unequal interval of time. So at last we can conclude that the car X travel equal distance in equal interval of time, whereas car Y travels unequal distance in equal interval of time. So car X is an example of uniform motion, whereas car Y is an example of non-uniform motion. Now we will come to the topic, that is speed and velocity. So to discuss speed and velocity, speed basically it is defined as the rate change of distance. Speed is the distance traveled by an object in a given interval of time. It does not have any direction. So speed is a scalar quantity. Velocity is the displacement of an object in a given interval of time, and it has unique direction. So speed does not have direction, whereas velocity is having direction. So speed is a ratio of distance traveled upon time taken, and velocity is the ratio of displacement upon time taken or time interval in which that displacement occur. The speed of an object can never be negative whenever an object moves. Okay, so speed cannot be negative because it does not have any direction. The length will always be there, that is the path length. It can be zero. This is because the distance traveled can never be negative. The velocity of an object can be negative, positive, or zero, because the displacement can be negative as well as positive, or can be zero also. Speed is a scalar because of magnitude only, and velocity is a vector quantity because of magnitude and direction both. Both SI unit is meter per second because it is just ratio of distance traveled to the time taken and displacement to the time taken, and distance and displacement are in meter and time is in second. Now what is average speed? Average speed when you travel distance, okay, suppose we are moving from Agra to Delhi, then after driving for 2 hours we will take an halt of half an hour, then again we drive and reach to Delhi. Now for that, average speed will be, and we have changed our speed in many times while driving. We have accelerated, we have deaccelerated, means we have increased our speed or we have decreased our speed while the journey. So the total distance traveled, average speed is the ratio of total distance traveled divided by the total time taken. Whereas average velocity, now here our motion is not uniform. Our motion is not uniform, and there's initial velocity and the final velocity. So whenever you are moving, there's an initial and a final velocity. Then average velocity is the sum of initial plus final velocity divided by 2 is your average velocity. Clear? So initial velocity, we will discuss what is initial velocity. When you start your motion, the velocity from which you have started up is your initial velocity, and when you have At any time interval, you take that point as a final point, and at that time the velocity is final velocity. There are some symbols of different quantities, like distance, it is usually used as s, initial velocity u, final velocity v, time t, acceleration a. Their SI units are distance meter, initial velocity meter per second, final velocity meter per second, time second, acceleration meter per second square. Now what is acceleration, that we have to discuss, because acceleration, the rate change of velocity with respect to time. The rate change of velocity means from initial point or initial velocity to reaching to the final velocity, there isn't some change. So final velocity minus initial velocity v minus u divided by time, that change occur in this duration. So the rate change of velocity is defined as acceleration. Now again, acceleration can be positive or negative. Acceleration can be positive or negative. The negative acceleration is given a unique name, that is either you place the minus sign, or you can write retardation or deceleration, but the SI unit will remain same, that is meter per second square. So the negative acceleration can also be noted as retardation or deceleration. Now positive and negative acceleration. Positive acceleration when the initial velocity is lesser than the final velocity. Suppose you have started your motion with 10 meter per second and your final velocity you reached is 30 meter per second. Suppose you start your two-wheeler and you start moving at 5 seconds, you are at 10 meter per second. Then you accelerated through your accelerator, means you speed up your vehicle. You will find out that your velocity is now 30 meter per second. Velocity is speed plus direction. Speed plus direction. Now acceleration is, and that time in which you have speed up is 5 seconds. So the acceleration will be final velocity minus initial velocity divided by time taken. The final is 30, initial is 10, divide by 5, so 20 by 5, your acceleration will be plus 4 meter per second square. Now this plus 4 is positive acceleration, means your vehicle is getting up, or the velocity of the body is goes on increasing because it is positive acceleration. And at what rate? At 4 meter per second your vehicle velocity is goes on increasing. Now negative acceleration, suppose while driving someone comes or a red signal on the street, then what you do, you start applying the brakes and slow down your vehicle finally to zero. Then the initial velocity is more than the final velocity. So whenever there is initial velocity is more than the final velocity, then it is negative acceleration, or it is also termed as deceleration or retardation. So let the initial velocity is 40 meter per second, final is 20 meter per second, and time taken is 10 seconds. So the acceleration will be 20 minus 40 divided by 5, it should be 10 over here, and minus 20 by 10, it is minus 2 meter per second square. So that will lead to a negative sign, that means it is indicating deceleration of 2 meter per second. Thank you.